most of this, if not all of it. Oh, well, maybe not. We'll see. So the inequality relationship between two real numbers is often applied in proofs. Now, something that we didn't talk about in that little example is the fact that, well, we'll just talk about this. This is just in general. These are general terms before we get to triangles. So if you have any number, A and B, A is greater than B if and only if there's a number C such that B plus C is equal to A, or A is equal to B plus C. Basically, in numbers, what that means is, let's just go off to the side. 4 is greater than 3, right? So an example of this is page 373. So let's just say this. If 4 is greater than 3, so that 4 is basically A in this scenario and 3 is B. The only way that 4 is greater than 3 is if we can add a number to 3 to make it equal 4. Can we add a number 3 to make it equal 4? What is it? 1, exactly. Write if with 2 F's. The reason why is because if with 2 F's means the same thing as if and only if. So 4 is greater than 3 if and only if 4 is equal to 3 plus 1, which is true. So basically, it's just saying that one number is bigger than another number as long as you can add a number to the smaller number to make it equal the bigger number, which is always going to be true, right? If you have a smaller number, you can add something to that smaller number to make it equal the bigger one. That's just kind of a mathematical fact, right? If you have 7 as one number and 3 as another one, you can add a number to 3 to make it equal 7, and that number is 4. So that's all this is saying. It says it in a very mathematical way, but that's all it's saying. All right, next thing. Comparison property of inequalities. Here's something that is almost like stunningly obvious. If you have two numbers, those two numbers are either equal to each other or not equal to each other, right? That's what this is saying. If you have a value of A and you have another value B, then A has to either be less than, greater than, or equal to the value of B. Those are the only options, right? Two numbers will either be the same or different. Kind of covers everything. That's all this is saying. So real numbers, I don't know why it includes B here. I don't think C, or sorry, I don't know why it includes C there. I don't think we need C there. Anyway, the following is true. Either A is less than B, A is greater than B, or A is equal to B. One of those three things has to be true if you have two numbers. It's just a fact. The transitive property. Hey, that's something we recognize, I hope. Now, the transitive property, generally, when we're talking about equations, because we've talked about the transitive property of equality, now we're talking about the transitive property of inequality. The transitive property of equality said, if you have one number equal to a second, and that second is equal to a third, then the first is equal to the third, basically meaning all three numbers are the same. This one is saying, if A is less than B, and B is less than C, then A is less than C. For example, just write this down. If 2 is less than, give me a number bigger than 2. 4. Okay. And 4 is less than, give me a number bigger than 4. 6. Then 2 is less than 6. Stands to reason. Okay. When you actually use numbers with most of these things, they become kind of obvious, which is nice. Now, it also works for the greater than relationship as well. If you have a number less than, one number is less than a second, and that second number is less than a third, then the first one is less than the third. If you flip it all around, the same thing is true. If A is greater than B and B is greater than C, then A is greater than C. If 6 is greater than 4 and 4 is greater than 2, then 6 is greater than 2. We can just kind of flip it around and say greater than as opposed to less than. All right. Questions about those? Solid so far? A lot of logic. Addition property of inequality, not addition property of equality. But the interesting thing is, the addition property of inequality works the same as the addition property of equality. The addition property of equality said if you have two numbers that are the same, they will remain the same if you add the same thing to both of them, which makes sense. This one is saying if you have one number larger than another, if you add the same thing to both sides, then this side will still be greater than that side, which makes sense. Like if you have, let's say, I'll just use 2 and 4 again. If 4 is greater than 2, which it is, then let's say 4 plus, give me a number that isn't 4 or 2. 6. 4 plus 6 is greater than 2 plus 6, right? If you add the same thing, to both sides of an inequality that's true, that inequality will still be true. 4 plus 6 is 10, 2 plus 6 is 8, 10 is greater than 8. So if you have an inequality, a true inequality, and you add the same thing to both sides, that inequality will remain true. Whether it's a greater than or a less than, it works for both of them. And it works for subtraction as well. That's what this last one is saying. So if you said, let's just use these same numbers. If 4 is greater than 2, then 4 minus 6 is greater than 2 minus 6. That's going to be true. 4 minus 6 is -2. 2 minus 6 is -4. -2 is greater than -4. So if it was a true inequality and you take away the same thing from both sides, the inequality is still true. Cool. That's what we got. Now, the reason why we're talking about this is because inequalities, believe it or not, can be used with triangles. The definition of inequality and the properties of inequalities can be applied to the measures and of angles and segments because these are real numbers. Everything that you have ever dealt with in your entire life has been a real number. Next year, when you get to Algebra 2, if you take Algebra 2, you will learn that there are other types of numbers aside from real numbers, and they're called imaginary numbers, and that's an actual thing. But you'll learn about it, and it's kind of cool. I like teaching it. It's good stuff. So if you take Algebra 2, hopefully I'm still teaching it next year, you'll get to learn about imaginary numbers and complex numbers. So turn the page. What's that? Yeah. So here we go. Theorem 6.8. This is the exterior angle inequality theorem, as opposed to the exterior angle theorem, which says the exterior angle is equal to the sum of the remote interior angles. Now, if you have an exterior angle and the two remote interior angles add together to equal that exterior angle, what does that tell you about the exterior angle? Actually, in the theorem, it tells you that that exterior angle is greater than the measure of either of the corresponding remote interior angles. Because if the remote interior angles add up to equal the one on the outside, that means the one on the outside has to be bigger than both of the ones that add up to equal it in the first place. Right? If the exterior angle is 100, and the two remote interior angles, one of them is 70 and one of them is 30, both 70 and 30 are less than 100. That's what we're saying here. That makes sense. So remember that each exterior angle of a triangle has two remote interior angles that are not adjacent to the exterior angle. That's what we reviewed in that little warm-up. So let's move along to example 1. Example 1 says to list. By the way, the words here, this is a lot more detail than what I'm going to need for you to write down when you do problems like this. I'm just going to let you know that up front. You can use a lot less reasoning than what they're describing here. So list the angles that satisfy the stated condition. Justify your reasoning using the exterior angle inequality theorem. So all of the measures that are less than angle 1. So what this is asking you to do is inside of triangle PQR, what angles have to be less than angle 1, which is an exterior angle. And so what it says is angle 1 is exterior, and the corresponding remote interior angles would be angle PQR, which is the combination of angles 3 and 4, and angle PRQ, which is the combination of angles 5 and 6. Those are the two remote interior angles that add up to equal angle 1, which means that the measure of angle 1 has to be greater than the measure of angle PQR, because that is one of the two angles that adds up to equal that one. So it's greater than angle PQR. It's also greater than angle PRQ, which was the combination of 5 and 6. For the same reason. So it's also saying that because angle PRQ is the combination of 3 and 4, and because PRQ is the combination of 5 and 6, that means that angle 1 is greater than angle 3 plus angle 4, which is the same thing as measure of angle PQR. And the measure of angle 1 is greater than the measures of angles 5 and 6, because 5 and 6 is the same as PRQ. So, because it's bigger than the sum of those, it also has to be bigger than those individual angles as well, right? If it's bigger than the sum of 3 and 4, then it also has to be bigger than 3 and bigger than 4, separate. So it's saying at the end here, the angles with measures that are less than angle 1 are angles 3, 4, 5, 6, and the sum of 3 and 4, PQR, and the sum of 5 and 6, PRQ. Does that make sense? Ish. So this is all about reasoning right now. There's actually no calculations being done in any way. So we're definitely switching gears based on what we've been learning recently. But we're still sticking with triangles. That's what's the similar thread here. So we don't need to worry about angle 2 or 7 when we're talking about measures that are less than angle 1, because we can only determine, we don't need to worry about 7, 2, or 8, by the way, because we're only talking about remote interior angles in relation to the angle on the exterior. So with angle 8, we're talking about measures that are greater than the measure of angle 8. So is angle 8 interior or exterior? Is angle 8 inside the triangle or outside the triangle? Inside the triangle. Okay. Now, angle 8 is adjacent to angle 1, so angle 1 is not the exterior angle for angle 8. Which angle is exterior in relation to angle 8? 2. 8 is a remote interior angle in relation to the exterior angle 2. So angle 2 is exterior of triangle PQR. So by the exterior angle inequality theorem, the only thing we can say for certain angles that are greater than angle 8 is the measure of angle 2. That's it. There's no other angles that we can say for certain are greater than angle 8, even though it certainly appears that angle 1 is greater than angle 8 because 1 looks obtuse, 8 looks acute. We can't say that because it might not be drawn to scale, and we don't have any numbers that we can deal with. So we can only go based off of the hard facts, and that's one of the hardest things I think about geometry, is to stick with the hard facts of the particular problem you're working on. Even though it looks like 1 is certainly more than 8, we can't say it because we don't have numbers. So let's try this one. So angle 1 is here. Now, there are two other triangles that we're looking at here, right? There's multiple triangles within this triangle. So we don't need to come up with a whole big long paragraph like we did here. Let's just kind of talk through it and make some statements. So angle 1 is exterior. Give me one remote interior angle in relation to angle 1. Which one? 7. Good. So measures that are less than angle 1. So let's just write them out. Angle 7. Okay. Certainly less than angle 1 because 7 is a remote interior in relation to the exterior angle 1. So angle 7 has to be less. Okay. Angle 7 has to be less than angle 1. What else? Which ones? 3 plus 4, which would be angle ABC, right? If we get the combination of 3 and 4, that's ABC. So angle ABC. And because ABC is composed of angles 3 and 4, it also needs to be larger than angles 3 and 4 separately as well. So angle 3, angle 4. So you kind of see how this is starting to work a little bit? Ish. All right, what else? There is one more. It is not 5, because 5 is not remote. 5 is adjacent. Which one? It is 6. Because 6, if we cut off that part of that other triangle, angle 6 is a remote interior of triangle DBC with an exterior angle of 1. So the other one would be angle 6. So those are the angles that we know for certain are less than the measure of angle 1. All right, let's move on. Any questions about A before we continue? So that basically is every angle inside both of these triangles except for 5. Pretty much everything except for 5. All right, measure of angle 7, angles that are greater than the measure of angle 7. Angle 1, how come? I mean, we already said that 7 was less than 1, right? So that means that 1 has to be greater than 7. So let's, yeah. If something seems obvious, take the obvious. We already wrote that 1 is more than 7. So yeah, angles that are more than 7 measure be angle 1 for sure. So angle 1 is greater than angle 7. Angle 5 with 7. I'm going to go with no on that one because 5 is not an exterior angle of triangle ABD. But if you look at triangle ABD, actually, let's focus on triangle ABD for a second. Just this one over here. Which one of the angles outside of triangle ABD is exterior? 2, 4, or 6 of ABD? Is angle 2, 4, or 6 exterior to angle A or triangle ABD? 2 is exterior to triangle ABC, but it's not actually an exterior angle of triangle ABD. The reason for that is an exterior angle is always part of an extension of one of the sides of a triangle. So BC is a side of triangle ABC. 2 is on the extension of that. If we close that off there, 2 is not an extension of AE, AB, or EB. Then it's got to be 6. You're right. 6 is exterior to triangle ABD because segment AD continues and 6 is right there, which means that 6 is exterior to triangle ABD, which means that angle 7 has to be less than angle 6. So that's the second one that we can say is greater than angle 7. There is a third one, and it is one that was already said, but it's for a different reason. And it's not 5. It's what? It's 2. Yeah. Because angle 1 is an exterior angle of triangle ABC. Angle 2 is also an exterior angle of triangle ABC. And 2 is not right next to 7, which means that 7 is a remote interior angle with 2 is an exterior angle. So 2 has to be greater than 7. So angle 2. So those are the 3 angles for certain that are greater than the measure of angle 7. Given no information about angle measurements. Yes, it looks like there are other ones that we could probably say, but we can't say it because we don't know if this is drawn to scale or not, and we don't have numbers. Any questions on that? This is some pretty it's easy for some. Once you get the visuals of it down, it's pretty easy, but it can be intense, just because there's so much going on, you're like, I don't even know what to look for. Once you understand what you're looking at and you know what you're looking for, it becomes a lot simpler. It's going to take some practice. Like most things in there. I want to talk about this, think about it for a second. I like this question. Why does that have to be wrong? Why are those markings incorrect here? Who can tell me? It goes hand in hand with what we've been talking about. Why is angle Q not equal to angle PRS? Why do we know that's false? What's that? We don't know if it's isosceles or not. Zach? Yeah, angle PRS is exterior to triangle PQR. And angle Q is a remote exterior angle with angle PRS, or sorry, remote interior angle with angle PRS as the exterior angle, which means angle Q has to be less than this angle here. Gotta be. So that's why. All right, let's keep going. Moving right along. Yeah. So let's see, angle side inequalities. Here we go. Now, in my mind, this second half of the lesson is easier than the part we just did. Because we get some numbers and it goes back to some of the stuff I was talking about on the warm-up. So we know that if two sides of a triangle are congruent, then the triangle is isosceles, which makes the angles opposites of those sides also congruent, right? If you have an isosceles triangle, I'm just going to draw one up here real quick. If you have a triangle that is isosceles, not only do you have two congruent side lengths, you also have two congruent angle measurements. We learned that back in the triangle unit that we did first part of geometry. So isosceles, two congruent sides, two congruent angles. So we're talking about triangles in general. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. All that means is what I was talking about in the warm-up. If you have a really narrow angle, that's going to be across from the shortest side. If you have a really wide angle, that's going to be across from the longest side. And then the one that's in between the two will have an angle measurement and a side length that are in between the other angles and sides. That's what it's saying. So, and then kind of the opposite is true here. If an angle has a greater measure than another angle, then the opposite angle with a greater measure is longer than the opposite angle with the lesser. So the side with the opposite measure. So here we go. List the angles of triangle LMN in order from smallest to largest. So all this has to do with is look at the numbers. And if we're going with smallest, we need to look for the smallest number first. Out of those three, which is the smallest number? MN, 5.4. What angle is across from MN? L. It's the one that doesn't use either M or N. It's the other letter, L. Which means that L is the smallest angle. Because it says the sides from shortest to longest are MN, and then LM, 6.1, and then LN, which is 9.5. So in terms of the angles, the smallest angle is angle L, followed by what? Angle N, and then finally, angle M. So angle M is the largest, angle L is the smallest, and then angle N is in between. Does this seem easier than the ones we just did? Hopefully. Yeah, I feel like this is a lot more simple to understand. So do this one real quick. These should be very quick problems to solve, hopefully. As soon as Chloe gets back. All right, what's the shortest angle, or not the shortest angle? What's the smallest angle? B. What's the next smallest angle? C. What's the largest angle? A. Great. Any questions about that? Cool. Let's move on then. That might be the easiest thing we do today. Next, we're going to list the sides in order from shortest to longest, which is the same thing as we just did. It's just opposite. The shortest side is across from the smallest angle. The longest side is across from the biggest angle. So that means we need to figure out what angle X is. And it already solved it for us. It said it's 39 degrees. And we can figure that out. That one's 51, that one's 90. Take away 51 and 90 from 180, you get 39. So angle X, 39 degrees. So if we are listing these from smallest to largest in terms of side lengths, which is the smallest angle? X. So what side is across from X? WY. That's the shortest side. It's the exact same problems that we just did, but instead of figuring out the smallest to largest angles, we're figuring out shortest to longest sides. Followed by what? YX, yeah, or XY, either way. YX or XY. And then the longest one? WX, good. Cool. So that's all we have to do for figuring out the order of smallest to largest angles or shortest to longest sides. Great. We're getting pretty close. Oh, we might finish today. This will be great. So there you go. How would you feel if I made tomorrow a work day? Be all right? Okay, cool. Let's do that. But let's try to get this finished up. So you can finish, well, anything you need to, but hopefully 6-3 and 6-4. All right. How many degrees is angle F? How many degrees is angle F? 79. Nice. So what's the smallest angle here? 45. So what's the shortest side length? FH. Shortest side always across from the smallest angle. What's the longest side? GH. It's going to be across from the biggest angle. So the one in the middle? GF. I don't use this word a lot in math, but easy, right? Like it kind of actually is. It's one of the few things that we can kind of say is a little bit easy. I really hesitate to use that word with math, but I feel like I'm okay in saying that, right? Okay. Let's go ahead and finish this up real quick. We got about 4 minutes left. During a game of paintball, opposing teams try to eliminate players on the opposite team. If you've never played paintball, that's how it works. Manny and Lynn are on the same team and they want to eliminate Logan from the game. If Manny, Lynn, and Logan are located at the positions shown in the diagram, who is closer to Logan? It actually tells us the answer. It says by the triangle angle sum theorem, the measure of the angle across from the segment between Logan and Lynn is 65 degrees. So the angle measurement with Manny looking at Lynn and Logan would be a 65-degree angle. And it's trying to figure out, Manny and Lynn are located. Okay, who is closer to Logan? Is Manny or is Lynn closer to Logan? So the shortest side is here, right? That's the shortest side. The longest side is going to be across from who? Across from Lynn. That's the longest side. And so the medium length side is going to be here. So Lynn is closer because the distance between Logan and Manny is the longest distance in that triangle. And the medium distance between Logan and Lynn is going to be shorter than that. And so it just says right here, 65 degrees because 65 is less than 76 according to theorem 610. Lynn is closer to Logan. So there you go. We can just use the reasoning that we just did on that. So here's the last question for you. I want you to figure that one out. Same reasoning, same type of method. Who should need to pass it to? Diego. Nice. Because the distance between Lucy and Diego is the longest side. So if Lucy is passing it and she wants to practice throwing farther, she would throw it to Diego. Excellent. I'll tell you what your assignment is tomorrow. Okay. Don't worry about starting this today. It's going to be kind of a long assignment. I'll just let you know. So actually, you know what? I am going to write this down. It's going to be 1 through, because tomorrow's a work day. This will be a bit of a longer lesson or longer assignment. 1 through 19. I'll also put this on Google Classroom. So it'll be 1 through 19. And then 21 through 35. 21 to 35. And and 39. So I'll put that on Google Classroom if you don't have it written down now. And we'll have all class tomorrow to work. So there you go. Have a good day.